It's fine. So start. Okay. Hello, hello, and welcome. Welcome back to another week in the Humble Dev's journey to building a SaaS in 12 weeks. All right. If you're watching and you can hear me clearly and the stream is visible properly for you on YouTube, please let me know, because there seem to have been a couple of issues in the last stream that I've had. But other than that, I think we're good for today. Mm, mm, mm. All right. All right. All right. Great stuff. So, okay, perfect. Thank you very much. All right. So, as usual, we'll start with a little bit of a review of what we discussed last week, just to make sure that you guys get that repetition in a little bit, and that we then, after that, jump into working on the backend, which will become the difference will become very evident a bit later on today. So, without further ado, let's start running through last week's info. So last week we spoke about the interactability with the DOM for JavaScript. So we spoke, and we also looked into some DOM manipulation, where we target various different elements of a web page using JavaScript in order to change these, update these, and by the end of last week's stream, we created very quickly a Kanban app, or at least we let Copilot create it on our behalf, where we had buttons that a user can submit a form, and when you click to create it, it would add these different tasks in the column that they belong, right? So that's all about DOM manipulation. So we're not going to cover all of the details here again. Looking at arrays. So again, arrays is just a list of items, or a list of objects, a list of any kind of data, right? And an array has a lot of methods that we can use. So these are functions that are pre-created within the JavaScript language that can help you to find something in your to find something in your array, to filter it based on any criteria, to do some calculations on it, as well as run through a function that allows you to, for example, do something for each individual entry of your array, right? And then we spoke, of course, about objects, which is one of the most important pieces of JavaScript that we will interact with, because especially as we get into the backend, we will be using objects quite frequently, which will become the norm for everything that we'll do in terms of data transportation between the front end and the backend, and any other service for that matter, right? So objects are similar to arrays, but are structured very differently, where each key value pair is how they call it, stored by name or sorted by name instead of by ID or index as it is for the arrays. We spoke a bit about the asynchronous events that you could have within JavaScript to make sure that you don't create scenarios where a user is waiting for something to happen that could take seconds or even minutes. But minutes is kind of extremely long, but it could happen where you're trying to get some information from a remote system, or read something from a database, or take any kind of action using JavaScript. And for that, we use um, try catches. So we use methods that will basically do the work kind of in the background and then report back when it's done. But most of this will also be connected to the backend that we'll speak about today. So we're going to scoop over this for now. Right. So last week when we spoke about asynchronous events, we interacted with some web-based APIs where we basically just request some data from a website. This is something that you normally would do with an async await function, which will again request the information and then basically just wait until the information is returned to it before it will then continue with this specific operation. But it will continue to work on other things if it has any during that time, right? We spoke about error handling, which is of course very, very important. We'll also be doing much more of that in the future. We spoke about AI integration, which we'll also be handling much more of today, because we do need to kind of decide on which AI platform we'll use, or which AI like IDE will we be using going forward. And this is a decision that you can make, of course, for yourself. I'm going to be providing a lot of information regarding what it entails, what you get, and the things that you kind of need to look for if you're using AI for development purposes. And then after that, you can, of course, make your own decision based on that. All right. So review for last week, very quickly done. Let's continue with JavaScript in the backend. And in order to better understand the difference between the front end and the back end, you can look at it like this. So everything that we've done so far, right? Oh, hold on, sorry, still using my still using the big camera view. Okay, so everything that we've done so far was purely front end related. So none of the scripts that we wrote, nothing that we've done with HTML, CSS, or JavaScript so far was targeting or using the backend to do anything, basically, right? So everything that we were doing was in the browser or on your phone or anything that the user interacts with. That is considered the front end, right? The back end is everything that we will do regarding data handling. So if a user logs in, so you log into your email, right? You go to a website, you can sign in, great, right? The moment that you actually authenticate, all of the information that is presented to you, so all of your emails, all of the information of your account, comes from a backend. So at some point, your browser needs to request to a server, okay, I have this user that is now currently logging in, and then it will fetch all of your data. And the backend has that information, right? So it's not on your PC when you open your inbox, right? So it's somewhere out there in the cloud, in someone's computer or someone's server, and it needs to get to you. And that is what we talk about when we speak about the backend. So everything that has to do with processing data, handling logic, handling your database structures, handling the security of the data. This is considered the back end of the application. And previously, and when I say previously, I mean in the time where JavaScript became a thing and it became widely used as the language to make web apps and websites interactable and more dynamic. JavaScript was only meant to be used in the front end, so only on the user's computer. So we've written a bit of JavaScript, we've tested it, but again, all of this was just running in the browser locally. And while that was the case, other languages were being used to handle the backend, right? So the backend was being handled by languages like Java, like Python, like C++, or PHP, for example. So all of these programming languages were written specifically to handle operations that would require access to the CPU, to memory, to a drive, to networks, and all that kind of information. This is something that was not a part of JavaScript during that time. And as JavaScript continued to grow and continue to become more efficient and to be and become more functional, at some point, someone thought, okay, why won't we just use JavaScript to also do backend work? It gets a little bit complicated, but we'll go through how that is achieved. Because again, everything that we've done so far in JavaScript itself as a language, when we use it, we're using it inside of the browser. And the browser as an application has a backend as well that it uses to talk to our computer. Because in JavaScript, when we're writing our script, we're never saying, we want to address the RAM, so the memory of the computer, or we're giving a specific instruction to the CPU, or we are writing a file to the computer, or changing a file on the computer. All of that does not happen using JavaScript in the front end. We just write functions, we write certain operations that we want to do, even like network requests, and these are handled by the backend of the browser that is installed on your computer. And that browser is then taking on the backend functionality of our JavaScript and then executing this without us like telling it to do any backend work, right? So JavaScript in the backend is done mostly through Node.js. Sorry, I had to check my stream. Okay. So it's done through Node.js, not exclusively. So there are alternatives for Node.js, but we're going to stick with Node.js because this is just the most widely used backend framework for JavaScript. And what it provides us are a number of things. So It provides us, of course, the ability to talk to the file system of a computer, whether that being a server or a PC, to use network commands, so request something outside of our computer, um, do all kinds of perform all kinds of instructions to memory, to CPU that are again not native to JavaScript by default. As well as it is non-blocking, so JavaScript in the browser is single-threaded mostly, which can create blocking events relatively easily if you're not careful with the way that you request things. And in the backend, JavaScript uses something that we'll cover in a bit to make it non-blocking somewhat. And then it is all event-driven, so there is an event loop that we'll cover in a bit that will basically be running all of the different tasks that it will be given through the front end, and handle these also asynchronously. It is still single-threaded. However, due to the fact that it will offload a lot of the tasks that require time in order for them to get performed, it doesn't wait for each single task to complete. So it will go through a cycle, and there are queues, which I'll show you in a bit, that will handle all of the requests in a relatively fast-paced manner that causes very little delay in general. All right. So as a very, very small example, we have, for example, a button that can be pressed, and that button needs to request information from a server, right? So a server is a backend. And then on the server side, we basically will have a listener. So there needs to be a server instance that is functional at that time, that is waiting for requests to come in. And that function is then replying. So whenever it gets the request from the front end, it's like, okay, I have been programmed to give you data that is in this path, right? So this is just a folder structure like we've already had before. And it will then respond with whatever data that we've allowed it to give out as a response, right? We'll cover these also in a bit. So what makes Node.js in functionality very different to JavaScript in the browser is mostly due to the event loop and how it handles requests. So this is the front end where the requests are coming from. Again, a button click, you scroll through a page and then more information needs to be loaded. You submit a form where you're giving information and this information needs to be stored somewhere. All of this is sent to Node.js as an application. Node.js has two stacks basically that it's keeping up. One is basically the requests that are coming in, and then the other one is the register callback. So basically, everything that it requests, for example, reading a file that might take a couple of milliseconds, writing to a file, merging a file, submitting something to a database, or requesting information from a database, or any kind of computation that needs to happen. So if we submit, for example, something that needs to be calculated, it will be handed off to the CPU or stored in memory or anything like that. And all of these operations are basically handed over to the operating system and put on a different stack. That will basically, whenever that operation is completed, the operating system will basically return the state or the information or the value that has been requested back to Node.js, and then it will pick it up and reply again to where the request originally came from. So this is kind of the event loop that makes Node.js run. This is very simplified, so there is quite a lot of complexity when it comes to understanding the event loop and how events are handled. But this is how it works in relative broad terms, right? And to maybe just kind of solidify how that would work. So we've seen the console log, of course. So this just logs some information to the console. And we have here 3 console logs, where the first one is just a string. We're just saying, okay, this is a statement, right? For the second statement, we are setting a timer for 1 second, right? So we're saying, okay, we are setting a timeout function, which means that we're telling JavaScript to wait with executing this specific command for a specific time, right? So we're calling up the function. We're like, okay, when the time runs out, this is what you do. So this is the actual command that we're providing. And the timeout is 1,000 milliseconds, which is just 1 second, right? And the third thing is, again, another console log. So because this is delayed, it will go back to the callback stack, right? So when this is run through Node.js, so this is again on the server side, so this is run on the backend, not the front end. It will print this. It will come to the second one, and it's like, okay, this one needs to be done later. So I'm gonna put it in my callback stack, and I'm gonna continue. So it's just gonna put it here. It's gonna continue with the third one. It's gonna execute this one. After this, there's nothing more that needs to happen. So there could be other things, and it will run through these. When it's done with running through the JavaScript file, it will then return to its callback stack, and it's going to be looking, okay, did I receive responses for the things that I requested, or did any timer complete by now? And it will then pick these up and actually execute them. So the result of this will be that you'll have this printed first. This will be handed off to the callback, so this will not be printed. It will then print the third statement, and when that is done, it will then print the second statement because it will be back from the callback. All right. So I hope this makes a bit of sense. And again, we can play with this around a bit later, but it's not. The point is not to get into all of the details of how this all functions. I will include some links in the Discord for this week's stream of some great articles that you can read that explain in like much greater detail the intricacies of how the event loop works. And you can browse through these. It's just important for you to understand that this functionality is there and that this is how the backend of JavaScript works. Because this can become important if you're doing any kind of troubleshooting or when you expect something to happen, but it doesn't happen at the time that you expect it. That's most probably because you've either overloaded the call stack, or you've maybe provided a computation that's quite large, which will take significant time to complete, and then the result will be delivered much later than you would expect it to, right? So it's important for you to be aware of that, because these are these kind of things that AI will not be catching very easily, because again, this is something that happens kind of outside of your application, and you need to account for that yourself. All right. So how do we get Node.js up and running? It is quite simple. So let me just go to my desktop, and we're gonna just jump out of the presentation very quickly to show you something. So for the moment, we've worked within VS Code, right? And we've not used anything else right now. So we've installed VS Code, right? And we kind of just used it out of the box. It already understands and autocompletes HTML, CSS, and JavaScript quite well. We already have GitHub Copilot by default, which already provides us with some like free like tokens and usage that we can utilize as long as we have a GitHub account that we can log in with, which is fine. Because again, like when we run all of these files, they're interpreted by the browser, and the browser is the engine that runs our application. Done, right? Because we're only handling the front end up to that point. So when we are now going to be tackling the backend, the backend is a server. So we also need to run that server locally on our computer in order for us to be able to build the front end and the backend functionality. And when we reach a point where the application is somewhat functional on both ends, right, front end and back end, we can then deploy it in a similar fashion to a cloud environment where we tell it, this is our front-end application, this is our back-end application, because there are many, many components of the back-end application that you don't want to expose to the general public. So these should not be visible or available to anyone coming to your website, again, for security, account information, database requests, you name it. And this is where the big divide will come in to separate our front end and back end as well. So to go through how that works, right? So we have Node.js. So I'm just gonna kind of walk you through how to get there, so it's more clear than me just having it already pre-installed and good to go. You can just visit the website, right? And if you just click on Get Node.js, there are a couple of things that you already need to know here. Because you can install Node.js in various ways, and I'm going to explain what's the difference between them and the way that I'm going to do it, and you can make your own choice there. But firstly, which version do you want to use? So by default, it's not even selecting the newest one. So the current version is version 24.7 as of now, but it's by default selecting the 22.19 version, which is it's called LTS, which stands for long-term support. And the difference is that the newest version will have more features that we will most probably not be using. However, it could be more problematic. The LTS version is considered something that you would be using in production, where you don't want to be updating your backend often. So you'll update this once every couple of years. And other than that, this is considered a version that doesn't change much, right? So apart from patching security vulnerabilities, this version should mostly remain the same during the time that you're running it without you needing to upgrade it or be afraid that it will break something in your build when you do deploy a new version, all right? So we're generally just going to stick with the long-term support version. You can, of course, use something else, but there is no need. At the end of the day, if there is like any specific functionality that you're looking for, that will be quite advanced, and then you can look into that. Then you select your operating system. I'm on a Mac, on a Mac, so this is what it selects by default. And then it's asking, okay, how do you want to install it? So using what tool, which is like even a middle layer for getting Node.js installed. All of this is not complicated. I'm just like running through it very concretely just so that you guys understand what's happening. So by default, it's selecting the NVM, which is the Node version manager, so Node.js version manager. And this is an official tool that will allow you to install and update a node on your computer and also run different versions. So if you are building your app and you're doing this now with version 22.19, and let's say you're working on your app for like 6 months, right? And within these 6 months, a new long-term support version has come out, right? So let's say this one is quite old. In 2 months' time from now, a new LTS version is going to get released, which is going to be based on like 25 dot something. And then you're like, okay, if I'm going to launch my app in the near future, I might as well use the latest version because it will be more secure than the old one. So what you could do with the Node version manager is like by default, install multiple versions of Node. So you're like, okay, I want to install 22.19 and I want to install the new one, which is going to be 25 dot something something. And maybe I also want to be using 24.7 for some reason. And then you can easily switch between them. So you can upgrade your app to the latest version, test it to make sure that it still works and that nothing is broken, or if there is like any part of Node.js that has been deprecated, so it's something that's no longer in use, then you can update that and continue your testing. So this is this is considered an official way or like a recommended way of installing it, but you don't have to per se, right? Another way to do that is by using Homebrew. So the Homebrew is kind of a command. It's a command line tool for Mac OS X to install packages from the web in general using the command line and update these also on bulk. And this is very commonly used in development, just so that you install all of these tools using Homebrew, and then you can just like update all of them. And you can do the same here. So even with Homebrew, you can install different versions of Node.js. And it really is going to be down to your preference. So when you change this, it's going to give you a different command that you need to run. So here you're going to have to run the Node version manager and then interact with it. And if you select Homebrew, then it will tell you, okay, then you need to use this, and then install Node, and you can check it that way. And by default, it will be installed with npm, which is the Node package manager, which we'll also be using to install other packages that are used by Node, which there will be plenty of. You can use Yarn, you can use PNPM. So these are different apps that do kind of the same thing. There is no specific preference here. We're going to stick with npm just because it's the oldest and most used in general. But you can look into the other ones and see if you prefer another one for your particular use case. All right. So having said that, you can also install it as a package. So you can just download Node and install it locally, which is something that for me, I don't do, just because if you install it manually, you're also going to have to update it manually. So every time that you want to install a new version, you're going to have to like download it and install it manually as well. I normally install it through Homebrew, just because I can just easily update it or like install a different version through the command line, and then Homebrew just kind of keeps all of the different versions separate automatically. All right. Okay. So having said that, where are we? Okay. So all right. So you guys can see this. So I'm just gonna go to the website, and it's like, okay, this is where we. Okay, so it's telling us first to install Homebrew. I already have. So if you want to install Homebrew, it's going to give you the same command line here. So you can just copy it and paste it if this is something that you're doing for the first time. So for me, I'm just gonna, because I can just say brew version, and I'm already running the latest one, so nothing to do there. So then it's like, okay, you need to install a node. And this package, so this version has a specific name within Homebrew, which is just called Node 22, which is fine. So we're just going to copy this, go to the command, and we're going to say brew. So the command brew basically says that Homebrew needs to perform this action, and we're going to install Node 22. So it's going to download the package, install it. Okay, so while that is installing, I do need to highlight something. So all of these tools that we're using are open source and free to use. That means that developers who work on software or create software, write their own applications, or work for companies that create software, have basically found that they needed a solution for something that didn't exist, and took the time to create that solution. And that solution has become something that is now being used by millions and millions of people completely for free. And this is something that is is definitely considered a luxury in the time where we live in, where we have all of these tools at our disposal that we can use for no cost at all. So just wanted to point that out. All right. So it's gonna tell us to check that we have Node. So Node version, which we have 22.14 for some reason. So we expected that to be 22.19. Where also it says here that it's 22.19, but it isn't actually, which is quite weird. Didn't ask us anything. Okay, that's fine. We can look into updating this to a new version later. But for now, let's we'll continue with that. So also npm is installed by default. Npm version, that's going to be 10.9, .2. So here it says should be .3. Okay. It's all right. It's all right. Okay, yeah. So there is seemingly no update. Okay, so these are seemingly considered the current working versions for these, which is okay. Okay, so now that we have Node installed, there are a couple of things that we need to know about using Node, right? So in order to run anything using Node, and there are many different methods, but we'll go through it a bit slowly just so you understand what happens. So we can create any file. So let's go to our code editor and sorry, let me just comment out all of this. Oh, nope. Sorry. Okay, so let's comment all of this out. Okay, no, that's fine. That's fine. So this app, for some reason, there's okay, was not commented out. Good. So this specific file, there is a naming convention specifically for using Node, where it expects your application for Node. So this is considered the backend, right? So our script for the front end is script.js or scripts.js or whatever you want to call it, or index.js. But the app is considered the backend. So that's why it's called app.js. And if we want to run this using Node, then we can basically just point it there. So we can, for example, in our so we can copy the path, we can go to our terminal and say we want to so we have Node installed, right? We saved a file that's just called app.js. We can just go to our terminal and just say Node. So we're choosing the application Node itself to run our file. But we do need to be at the directory of where this is. So I'm just going to cd to that location. Okay. So this code, and then this is new task manager. All right. So here is our app.js. So we're just going to say node app.js, and we're getting invalid config, which is great. Parent object. Yeah, okay. Great. So that doesn't work, which is logical because we haven't actually said that we wanted to use Node. We're gonna circle back to that in just a second. All right. So this is the general gist of it. We'll fix that in a bit. Don't worry about that. These are things that you will have to deal with on pretty much a daily basis as you work on the backend. But there is a little bit of time that you need to put into to kind of settle into things. Let's continue with talking a bit more about the setup for Node, and then we'll use it in our project for real. And you'll see how to set this up in just a bit. So npm again is the Node package manager, which we installed by default as we were going to install this. So again, when we chose the version, we're like, okay, we're on Mac, we're going to use Homebrew, you can use something different, and we're going to use it with npm by default. And this is where the Node package manager comes in. So what does it do? It manages our package.json. So basically, when we build a project, and at the start, you will only have a few things. So when we started and we were only just creating an application, or like the front end actually of the application, using only CSS, JavaScript, and HTML, CSS, and JavaScript, we didn't have that many files. And there wasn't like any version management of like JavaScript specifically to deal with, outside of knowing what does or doesn't work in the browser. When it comes to the backend, it's a totally different story. So when you install Node, you need the Node package manager because it's going to keep track of all of the various dependencies that you will have in your application. So there is going to be a package.json, which is your just like a manifest of everything that is being used. So all of the different packages, the versions of these packages, dependencies that you have for even like the packages that you have, as well as if you want to run something only in dev. So when you are developing your application, because there will be something that we'll use in a bit that we'll only be using for development and not when we use it in production, for example, as well as any custom scripts that you want your Node environment to do when a server is started. And to do that, npm itself has its own commands outside of like using Node. So we need to we can initialize projects by just saying npm init. We can install packages just like we do with Homebrew, but using the Node package manager. And we can, of course, use npm to start our server, as well as do a variety of other things. We'll get to that in a bit. So this is how the manifest file will look like. So the package.json again houses all of your application information. So this is a very small snippet, but even a small project will have a relatively large file. All right. But to point out here, you have general project information. So again, this is backend information. You have some scripts that you can run. You have your dependencies, as like for every package that you're using, it will identify the lowest version that the application expects to have in order to work properly. And what this is used for is that if you have started working on your application, right, and you are continuing to work on it somewhere else, on like a different PC, or like you've posted it to GitHub and you're downloading it somewhere else, just by running npm install after installing Node.js, it will install all of the packages for you. You don't have to go in and install 100 different packages that you've installed how do you call it, that you've installed over time as you're building a project, as you need new packages. It will just install everything for you, and then everything will be configured like it was on your PC that you were using before. All right. Okay, so let's maybe do that before we jump into the HTTP server request part. Sorry. So in here we don't really have. So this is the app that we built last time, which is fine, but we haven't yet initialized anything. So if I go back to my terminal, right, we didn't initialize a project at all. This is partially also the reason why this doesn't work, because it's like, okay, there is not much. So just keep an eye on this folder as we run npm init inside of this project. Okay, so it's saying interesting. Yeah, all right. Okay, cool. Sorry, it's been a little while since I've used npm for the first time on a computer. All right, no worries, no worries. We'll get through this. So we're trying to initialize, right? So let's do the sensible thing and go to the documentation, and we're like, okay, we want to initialize, so we know that this works, right? And if we want to start using npm, right, what is the thing that we need to do? We have our terminal right here. We know that we have npm minus version, yeah, 10.5. We can also say npm help init, which it's telling us. So it's like, okay, we'll guide you through, which is fine. But at the end of the day, we are now coming to the age of AI. So this is going to be like the whole manual document of like using init, which is great. But that's not what we want. So I'm like, okay, we can make this very, very simple for ourselves. So we know that we have this version running, and then we can just simply say that, okay, we're running this inside of this folder, right? So we can simply just copy this and okay, so we're going to copy this and we're going to use our friend here, and we're just going to go in ask mode because we're not going to ask it to write code. And we're like, okay, we are trying to use npm init to for this project and are getting the following error. You can do this, of course, outside of the code editor itself. I'm just putting it here so that it provides you with the with everything within the window. So let me just make this a little bit bigger so that it's more readable. Like, okay, yeah, okay, sorry. So I caused this problem myself by creating this manually, because I was just making some templates for the video, and that is what it was complaining about. So let me rename this, and because we're not going to use this one, at least not for now. Okay, so all that to tell us, so I don't need to go through all of this. So the file isn't there now anymore. And we can just run npm init again. Okay, great. So now it's like, okay, okay, sorry. So that was all my fault. That didn't run the first time. So I had already created the file that it would otherwise have created. So it was like, okay, you already have the file in place, so you shouldn't be initializing a new project inside of the same folder. So my bad. So now it's asking, what is your package name? So I can give it a new package name. If I don't, it's gonna provide the name, whatever is here between the brackets. So I'm just gonna say Kanban board. Your name can contain capital letters. Oh, okay, it's fine. Kanban board. So no capital letters. So it's version 1. So it's asking me to choose a version for my application. Sure, it's version 1. If you're making an application for the second time, you might want to do something different. I'm just gonna press enter. Description, a Kanban board for task management. Entry point. So it's asking me what the main app is going to be. I just want that to be app.js. Test command, I'm just going to skip that for now. Git repository, we won't add Git now. We still need to go through these keywords. Just Kanban author. Okay, so the author is important, but we'll get to that later. So once you publish your application online at some point, having an author in your app, documentation as well, having a license, or at least using a license like MIT or something similar, is going to be important for people to understand if they can reuse your code, and if there are any limitations that you want to place on that, or that you want to remain fully the owner of your application and no one is allowed to like use it, adapt it, redistribute it, like giving it to other people. So here it's going to ask us about the license. Let's go with just MIT for now. It's going to give us a brief rundown of our current configuration file, and that is okay. So yes, and now it has created the package.json for us, right? Good. So this is very bare bones, right? Because we haven't installed any packages, right? So as of now, this is a very lightweight configuration. So we're just going to create a new file, call it app.js, because that's the file that we indicated. So this is going to be our main. So this is the entry point of our application. So we must have that file available, right? So console.log hello from Node.js, sure thing. And now let's give it a try. Okay, so now it works because we did initialize the project through npm inside of our folder. So it gave us the output that we expect. So we told Node to run our application, and it did. And the result is that it gave us the output, whatever is in here. So if we if we run it again, we will get two outputs here, right? So this is so far very, very similar to what we've already done with the front end. But we'll get to what makes the backend very different in just a bit. So in order to do that, let me go back to my slides and continue. I hope everything is clear. If it is, please chime in the chat and let me know if you have any questions. But hopefully, so far it is okay. Okay. So all right. So we've already spoken about the fact that the front end will send requests to the backend. And in order to reply to these, we need to build APIs or API endpoints that can respond to these requests and take action upon them. And to start building these, we need a couple of things. So inside of an application, a backend application file, we will be utilizing many different packages. And for these, we need to define where they come from. So inside of our backend, here, this is a sample of setting up a server where we start with saying that, okay, we want to import the server functionality, which is an HTTP server, and from Node, right? So we're saying, okay, this is the Node HTTP server. That's the one that we want to use for our communication. And you already know const and naming const. So basically, we're setting here a fixed variable. So this is going to be a fixed in value. And this is a default naming convention for naming your server. This is the one that will respond to the requests. So we're setting up a const as a server, and we're like, okay, we're going to create a server, which is a function of the HTTP server of Node, where there are two parameters. And this is, again, default. This is just a default template that we're using, where there is a request, and this request is going to come from the front end, so from your clients. And there is a response. So the rec is the request from your client, and the response is the response that your server will provide. So again, this is from the backend. And it will start with response.writeHead. So this is going to be the response header, which will be sent immediately after the request has been received. And if the request hits an endpoint that the server accepts, it will respond with a 200 code. And 200 within HTTP protocol means okay, that we've received your request is accepted, and you will receive a response at some point, right? And it's going to also set the expected delivery method, which is generally going to be content text plain, right? Or more commonly, it will be Java JSON, right? It will be text JSON and instead of plain text. And then the response end, so whenever the functionality that has been requested is available or the information has been delivered, the response end will basically deliver the actual response to the request. So if we are requesting, I'm going to show you a snippet in just a second. So in here, we're just responding with a string, just saying hello world, but we can be responding with, an output of a list, or even like a filter of a list, or an object or something like that. But outside of setting this up, we also need to set up our server to be looking or listening out for requests. So the server itself needs to serve information to the client. And in order to do that, it needs to be listening for requests. So as we do this for now on our own machine, we're going to set up the server to listen right? So again, this is a function of the server that Node provides. By default, we're going to do this on port 3000. I can explain more about ports if that's something that you want. If there's no need, we're just going to stick with 3000 for now. And we're going to say, okay, this is the IP on which we're listening. And if you know IPs, you would know what this means. If you don't, this very specific IP just means for every computer that this points to itself. So this is the address, that's always the address of the computer that you're using. So we're saying to the server, you need to listen for requests on port 3000 and on this IP. So basically on your own IP. And then basically it's like, okay, something needs to happen when the server function is being called, and this will be continuous. So this is not a function that will run once and quit. So the server will run and it will keep on running. So we're like, okay, when the server runs, we would like to see in the console, at least for now, that is actually available. So if we go back to our little snippet here, okay. Let me just uncomment this just to make it a bit readable. All right. So again, this is the bit of preparation. So we are requesting the HTTP server. We're like, okay, this is what the server needs to do, and we're gonna let the server listen on this port. All right. So generally, your imports will all be at the start of your file. So there will be we'll build this out as we go. For the moment, this is something that is very simple. So we're just saying, okay, this is a this is a functionality that we're looking for. So now if we run this, right? Yeah, okay, that's fine. Module 2. Okay. That's fine. So it's just complaining about the way that the server is being called here. Well, that's okay. We'll tackle that later. For now, so all that we need to do is go to our local host, port 3000, and you see that we get the response. So all what the file does at the moment is it's like, okay, if you receive a request, right? Give a 200 reply and send the response, which is just a string. So there is not even an HTML file. There's nothing. There's no actual document that we're receiving, right? So it's just writing this to the browser window as the plain text. And if we would look to if we'd open our development console, and we go to network, for example, and we refresh this, you see that, okay, all that we get is an okay, so the 200 that we programmed in, and there is no there isn't a whole bunch of data that we're getting. We have the DOM object that is there from the browser, but there is no like any specific data that we have that is being passed through here. Because again, all that we are getting is saying, okay, when you receive this request, but this is server functionality. So we had none of this, right? When we were just writing JavaScript for the front end. Now we're connecting to a server. Again, the server is running on our own computer, but it's a server instance nonetheless. And this is how a server will still behave when you publish it online at some point. But for now, we're doing this all locally. And it's responding with the response that we told it that it should provide. Easy, right? So, but that's not all. So this is just the tip of the iceberg when we talk about the backend, right? So all that we've done now is installed Node, initialize the project inside of a folder where we want to build our application, and set up the server to listen to a request on a specific port. And we run the file. It's listening now, and because it's listening, also you can see here that it didn't return, so the listening continues. Because if we would exit out of this, so I'm going to exit out of the function. So just with Control C to close that functionality. And if I would now go back to localhost, it's not providing us anything, right? So the server is not there anymore, and there is no information that is going to send back to us, right? So that's what the server does. I hope that's clear, and I hope I didn't lose you with that. But believe me, it will become much easier as we continue, or at least you will understand it better as we'll move on. So now, having established what Node is, what it does, and what makes it different from just using JavaScript in the front end, now we have to talk about APIs. So RESTful APIs, or just REST APIs for short. And this is going to be the infrastructure that you're going to be building for your backend that defines what kind of functionality you make available for users on the front end of your application, right? So an API is short for application program interface. That means that you are going to script some logic that will allow, in principle, any application, but in practice, this will be the front end of our own application, right? Just like we interacted with an API last week, right, where we got information about a Pokemon from an API that's publicly available online. Again, you can use this for weather apps. You can use it for a whole bunch of other things. You are here going to design your own APIs. So whenever your user is using your application and they press on a button, you need to create backend functionality, which is the API, that will get that request, decide what to respond with using that request, and any limitations that you want to place on it, right? So anything that has to do with authentication or like getting data, running functionality, and all these kind of things, all right? So the REST API, so REST itself, basically just stands for the representational state of the information that's being transferred. And the key principles of the REST APIs is so these are routes. At some point we will get into using our framework where all of this will be pointed at as will be called routes. But for now, these are basically endpoints. So these are the resources that you make available. And there are various methods. There are only a couple, so this is not very extensive. But there is a get method to get information. So now when we used our application here, even though we didn't like state this very clearly, this is a get method. So we're basically requesting information from the server, right? So we're retrieving data. We can post information, and this will be like if we have a form on our website, right? So when we had our little Kanban board, so whenever we fill in this field and we submit it, so we click on add the task, this is a post to our server, to our backend. So we are sending this information to the server and telling it we want that information to be added somewhere, right? So we don't decide where it goes. The backend will do that. But we have been given this form, and we as users can only just click the button, and then the backend will have to know what to do with the information that it receives. So that is where the post method comes in to submit new information. And then you have the put or patch method, which is to update information. So if you have, for example, submitted a form on a website to provide your name, email address, phone number, you name it, and at some point you want to change your phone number, that is a put or patch method, because you're like, okay, the phone number already exists for my account, but I have now a new phone number and I'm going to provide it. And the server needs to know that it needs to remove your old phone number and put this phone number in its place, right? And this needs to be scripted out logic that you would need to provide. And then there is delete, right? So if I don't want to use a phone number on my account at all anymore, if in the platform allows for me to delete that information from my account, then I can just delete it. And again, the path or the endpoint that I'll be reaching should understand that, okay, now it needs to get rid of my phone number altogether, right? One important aspect of the REST or RESTful API principle in general is that it is stateless. So there is no how do I make this very clear? So when you send the information, all the information has to go in one go, because in your application, your server will receive the request, and the request needs to be complete. Otherwise, the task can't be executed. So if I go back to my sample, where I hope I have something here that will show it. Not really. Okay, we'll write something out in just a bit. But when you send out a request, so when we're like, okay, we have a post method. Again, if we look at the example of our application here, we entered some information, we submit it, we have a date. So this name and date, for example, would both have to be filled in for our task to get added, because our function here, or like our API endpoint in the backend, will need both in order to put the task where it belongs, right? So in which column does it go? And if both pieces of information weren't provided, then the logic will not be able to complete its functionality for the backend, right? So this is where making sure that on the front end, we don't make it possible for a user to click this button without providing both fields, right? And this is where kind of knowing what you're building and how to validate it becomes very important. All right. Okay, moving on. We've already mentioned that JavaScript in the browser doesn't have functionality to talk to the file system at all. And that's why when we were building our Kanban board before, the only functionality that we could have was to export the information in our current board as a JSON file, and then import it later by like uploading the file from our computer. Because the browser, or at least our application that's running in the browser, so the front end, can't say to the operating system or to the file system that, now I want to create a new file or I want to update a file, because that's just simply not allowed within the confinements of the browser itself. So with Node.js being an application that runs on the like it runs the backend on our operating system, and because it runs as an application, it's not a browser. It's still powered by the browser engine, the V8 engine that Google created, but it uses a different library that is based on the C language that does all of the operating system interaction. And with that, it can talk to the file system. So it can read files, it can write files, it can update files, and it can also do network requests and all these kind of things, right? So here, for example, we have a sample. We're like, okay, so this is just requiring the file system functionality within Node, and it's like, okay, I want to read a file, right? And then it's like, okay, this is the data that we'll have. We can, this is all asynchronous, just like we did the try fetches, right? For requesting something from an API. Here for writing a file or like reading a file, this might take some time, right? So we're offboarding this functionality to the operating system. And whenever the operating system comes back to us and it's like, okay, your file has been updated, then the event loop will basically, get that task and present whatever information it needs to the front end, if any, right? Because at the end of the day, we can have an error. We can like just write something and not provide any feedback to the front end. So all of this is mostly asynchronous. But we also need to make sure that this is coded in a way that these operations are asynchronous from the Node.js part. Okay, so we'll build something very quickly with Node.js, but there are a couple more things that I want to kind of run through before we do that, and then we'll have some fun with Node.js. So doing some front end and back end, and also introducing some very basic packages that we will use for Node.js that are considered like the de facto way of using Node, like at all. And I'll explain why that is in just a bit. And this is where AI will also become super, super important, because as someone who is just starting out, or even for experienced people, it just saves a lot of time. So where you would need to otherwise define all of your endpoints manually and add all of this functionality in there, which can, of course, be very time consuming, you can, of course, ask AI to generate all of the different functionalities for you when you have already predefined these, of course, for yourself in terms of what they should be doing. So the question is then, what should we use? So far, as I've already highlighted a couple of times, we're just using Copilot. So we've just installed VS Code. We've just signed in to GitHub. I mean, I hope that you guys have done that already. And that's it. So Copilot. So if you click here on the little Copilot icon at the bottom of your screen, it will show you your code completion. So there is a limit to these. So you get 5,000 of these, I think, a month. We haven't used much of these. And there is like a chat messages quota that you get for free, and otherwise you have to subscribe and pay for it. So we haven't used much, because I don't use this environment specifically outside of these streams. So this is barely used. But if you're going to build an actual application, you're going to be using plenty of these on a day-to-day basis. So then it becomes important to know what are your options. If you're going to be paying for one of these AI assistants, or if you're going to subscribe to them in order to build your application, for you to at least have a high-level overview of what your options are and what it entails. Okay. So okay, or we'll get to Express in just a little bit. So let's start with Cursor AI. So Cursor is for some reason Cursor always opens in Chinese for me. I really have no idea why. But if you have learned anything about paths recently, this button should ideally, at least I think, it says login here. I thought this was to change the language. Normally, you would like preferably have an easy way for your user to change their language. So here it says that it's Chinese. I can change it, but if I look here at the path, it says CN, which is short for Chinese. I can just change it to EN, which is short for English, and then I get the English version. So basically, I've now switched to English without using the interface. So Cursor AI is, I think, one of the most well-known code editors with embedded AI functionality. It works very similar to VS Code. Actually, it is VS Code, so this is a fork of VS Code. So VS Code is open source, so any company can just copy VS Code and build off it or make their own version of it. And this is what Cursor has done. So basically, they've taken VS Code that we already use, but they've kind of changed the interface to something that they prefer or something that they think works better than the standard VS Code implementation. And it's good. I use it myself. At the end of the day, I'm not like marketing any of these to you. It's at the end of the day up to you what you do want to use. For some reason, we've gone back to Chinese. So you can use it for free, and it gives you some like free utilization, just like we have for VS Code, right? You can subscribe, and it gives you a budget of some requests, and there is like a bit of a calculation, because when you use the different models, even here, if I click on these are the different AI models that we can use. You can also add one yourself. You can see that the usage is counting for one. But for Cursor, for example, they might have ones that cost half a credit or even a quarter of a credit based on an agreement that they have in place for cheaper pricing or more utilization. So this is one of the options. Another one will be, so hold on, let me just go back to, okay, it already browsed me away. So okay, so the cost, right? You can start for free, and then it goes up to 20 a month, which is, I think, sufficient for anyone building a relatively small project. Should be perfectly fine. Then we have Windsurf, which is a direct competitor to Cursor. It's a very similar kind of experience. Again, it's a fork of VS Code, so it's going to be looking and functioning like VS Code mostly. It has a bit of a different pricing structure, so where and it's cheaper, but also on the Cursor part, it doesn't tell you exactly how many what is your limit. So it doesn't so basically every request that you make will kind of have its own calculation, where on Windsurf they're like, okay, you get 500 prompt credits per month for the $15. And if you're using a model that is cheaper, so only uses like half a credit per prompt, then basically you can use 1,000 prompts. That's what it comes down to. And it supports like many of the same models that Cursor AI uses. So these have more integrations with more AI models than GitHub Copilot uses by default. But again, it really depends on what you use and whether this makes any difference for you. So okay, but generally it is mostly the same, right? And of course you have GitHub Copilot itself, right? Which again we already use for free, which also gives us a relatively good free tier. But also for this one, you can subscribe to it. This is the enterprise planning. There is also an individual planning somewhere here, which I saw not too long ago. Interesting. Yeah, right here. So you can subscribe. So you have, 50 chat requests a month. You have your completions, which is 2,000 per month. These are like when you click on a field and it automatically generates something for you and you accept it. That's what these completions are. But you can subscribe for 10 USD a month, and then it gives you, according to them, unlimited usage of like specific models. So this will not be like all of them. You get access to some others, but this is quite affordable. So it's something that you could consider if your experience with VS Code and the models that they have is good enough. Now, uh, the important part for me to stress here is that your experience on the platform itself or on the app itself will be dependent also on the model. So if you're going to be building your app using, for example, Cloud Sonnet 3.5, which is quite old by now, to be honest, Gemini 2.5, I personally do like because it strikes a good balance between telling me what it thinks and what it does, and not veering too much off track of what I asked it to do. ChatGPT is also quite good. GPT-5, I've not really used much to have an opinion about it. So these models will basically kind of you have to start your project with each one of them and see what it gives you and which one gives you the best result as a starting point, and then keep on using the same one going forward for consistency, because each one will have its own way of interpreting your code, and you would preferably have one that you use and stick with for building your application than changing it very frequently and then possibly breaking your build, which is something that can be very easily done with AI. So this is something that will also, so in the next stream we'll be focusing on solidifying our environment. So we're going to be setting up rules within the VS Code environment for AI to respect when we're building our application. This is going to be a very important thing for us to do in order to make sure that the AI wouldn't break our application once we have everything up and running, and we want to keep on adding functionality, as well as so we'll be setting up some rules and explaining what these rules would do and why they're so important, and like some variations that you have in setting up your rules, as well as setting up GitHub, understanding how GitHub works, how can we push our code to GitHub and basically create copies of our application as we build it, so that if at some point we do break our build, that we can just go back to a previous version and continue and try again, basically. And we'll also be doing branches and all that fun stuff. All right. So now, having spoken about some of these tools, there is one more that I want to highlight, which is from JetBrains. And this is, so JetBrains makes IDEs, so integrated development environments like VS Code for enterprises. So they don't generally target the hobbyists or like a one-man person, a one-man company or something like that. But their WebStorm IDE is free for non-commercial use. So if you're just building an app that you're not going to be charging money for, then you can use their IDE completely for free. It also has built-in AI and all of the functionality that we have. It's just a very different experience. So the JetBrains IDE has a very distinct experience, And you can look these up for yourself. I'll leave these links as well in the Discord server. You can have a look at them and even like download them and install all of them and give them a try if you want, or just stick with VS Code. With VS Code, it's all up to you. Now, apart from a complete IDE, so like an application that you use to write your code, there are also add-ons for VS Code. So Copilot itself is an add-on to Visual Studio Code, even though this is now completely baked in. But you can like get rid of Copilot altogether if that's something that you don't want in your environment. You have something like Klein, which is again like an extension very similar to Copilot, but you have to configure it yourself. You have to add these models yourself, so you kind of have to go to the providers of these models and get your own API key to use them, or like AI key to use them, and set up that way. You have also Kilo code, which is also like very similar to Klein. Again, it's an add-on to VS Code, so you keep on working on the standard VS Code basically, and it adds like all of this functionality. It kind of gives you the freedom to use whatever AI model you want. You can even host your own if that's something that you want, and not use one that is already pre-hosted by a company. All right. This is mostly for professionals and companies who like create their own AI models for their own use cases, and they want to use these and not use the public ones. And all of this is still just using an actual IDE like Visual Studio Code. However, there are, of course, many browser-based IDEs that you could use, but I personally wouldn't. So if we go to the most well-known one, at least I guess so, Lovable .dev, for example. They have really come a long way. So you can build web apps using them, but the reason why I don't and why I would not advise it is for two reasons that are for me very, very important. One is that every platform, so Lovable, you have bolt.new, I think. Yeah, so you have bolt.new, same thing. You have V0 by Vercel, which is Vercel is a platform that we're going to use, but and it's like so V0 is made by Vercel, and Vercel is made by the company that made Next.js, which is the framework that we're going to be using to build our app starting next week. But it's like an ecosystem thing, but we don't have to use the ecosystem. So, but to kind of explain my point is that Lovable, they have their own tech stack. So they have predetermined what framework they use. So what is the front end? What is the back end? What database model do you use? Your interactions, payment terminals, these kind of things, in a way that you can't change. So if you come in here and you're like, okay, build me an application, and it will. Okay, I'm not saying that it won't. You can't decide for yourself what front end, back end, or database structure or anything that it is that you want. So this is more for small projects. If you want to build something relatively simple and you're okay with whatever it is that they have baked in functionality for, then you can do that. But here comes then the next part. Pricing. So when you use VS Code or Cursor or Windsurf, you get firstly the choice of various models that you can use. Secondly, you could even host your own or go to any other model and you're like, okay, I'm going to manage my models. I'm going to add one myself. So it gives you a list of providers. and you put in your own API key to use that model specifically, whether you paid for it outside of like Copilot or VS Code, or like you're running something for yourself, or you get a free code from somewhere, it allows you to do that. But web-based AI coding platforms don't give you that flexibility. So it's like, okay, you get 5 daily credits. Okay, that's it. Up to 30 per month. So if you're trying to build an application, giving 5 prompts a day won't get you very far. So very, very quickly, if you really want to build and launch your app, you either have to like wait every day for this little bit of usage that you will get, or you're going to have to start paying. And as you can see, it's not that cheap in compared to like something like Cursor, which again, like their pricing is not very definitive. So they're like, okay, 20, you get more free use, but they don't say exactly how much. But it will definitely be much more like usable and get you much further than paying 25 for 100 credits per month, right? And again, like you can choose for more, but that means that you're going to be paying much more. So at the end of the day, what their target is that you start to build an app that you love how it looks and like the template that it uses by default, and that you just want to continue doing it here. And the other component that for me makes this a no-go to build like a real application is that you don't have any of this. So you have like a file manager within these web-based AI coding agents, but you don't have the freedom to like manipulate your files and like integrate any solution that you want, or use packages that you would want to use, or that you just found by looking into some kind of functionality that you want to have for your app. So it limits your freedom in like building the app the way that you see fit. And it has to adhere to whatever functionality that they provide for you. So this can become like very expensive, much more expensive than doing it using an IDE. And this is also targeting people who like don't want to install an IDE, just want to like just do their own thing outside of that, right? But for me, like the lock in to having to build all of it here, and then again, you can like come to this to Lovable or to V0 or to Bolt and like create the foundation of your app, so to speak, and then copy that over, or like download it and start using VS Code for it. But in my personal experience, that hasn't really been that valuable. So because it already defines a lot of structure for you, it already like creates many files and a lot of like things around your project and whatnot that you might not need, which can also throw off the AI model that you're going to be using in your like local IDE to build your app further. So for me, I prefer to just plan out my app and like use my IDE to like build it from scratch, instead of relying on these platforms to build it for me. I've used it to build just the front end, which is fine. So it kind of doesn't do like all of the backend functionality all too much, which can be handy. But you can also use how do you call it, like component libraries for that, if that's really something that you're looking for. And the same goes for like Bolt. So again, you get some free usage, which is not much, to be very honest. So if you start to build an app and you do like 5 or 6 or 8 prompts, it's going to be like, oh yeah, you've already exhausted your daily limit. Come back again tomorrow, and you'll be very quickly through your like free usage, and then you're going to have to start paying for it. And again, this is not like super cheap. And the same goes for V0. So all of these are relatively the same in what they provide. V0 is again, you can I mean, I wouldn't say this is not unique to V0. So both Bolt, Lovable, actually all three, and V0 all provide you ways to automatically launch your application as well. But again, like they kind of take the control away from you. So you can't decide where to host it, or whether it's going to cost you money or not. So it's kind of just vendor lock-in all the way. But okay, at the end of the day, you make your own decisions. I just wanted to give my own perspective and explain why I don't personally use them, or at least not much, or not for any like actual project that I want to build and complete. But I use it more for prototyping. So if I just want to create a prototype of a project, just to get some ideas or like play around with the idea, then it's great because it just does like everything kind of on your behalf. But not for any like serious project. And everything that I've just said is basically here in the slides as well. So local, right? So full control. You can work even if you're not connected to the internet or whatever. You have much more powerful, like you have much more control over everything that you do in your project using in IDE. And you don't put all your files and your information, of course, in a cloud environment. The negatives for like using local for me are very negligible, to be honest, because at the end of the day, if you're going to develop an application, you might as well know how to set up your development environment. And to be honest, it's relatively straightforward nowadays. It used to be much more complicated, but now there are so many tools that take off all of the complexity away from you that it is really quite simple. One like very slight consideration is that if you have a very weak machine, like you have like an old laptop, for example, that you're using for this, it might not be a great experience. But again, yeah, it shouldn't really be a big problem for most people. And yeah, if you don't work in a team, then this is not important. And for the web-based ones, all of the things that I've already mentioned. But it does have some advantages. So you don't need to set up anything. You don't need to pre-plan anything. You just tell it what you want to build, and it just goes off and does its own thing and comes back to you with what it thinks that you want. But with that, it really takes away control from you. You have to be, of course, online in order to use it altogether. They're also not that quick, to be honest. So most of these do take quite a bit of time to build something for you, which can also be time consuming, because if it doesn't get things right, firstly you'll be out of your free limits very quickly, and you have to wait for quite a bit for it to generally start building something for you. Yeah. So that is all in terms of just explaining things today. So let's get in here and actually build something. Okay. So let me start by, it's not about the building. I just want to show a couple of things. So for us here, let me, do I still have my, okay, so this is the new one. We don't have much in here. We have the package.json. We have the scripts from last week, which is fine. Okay, so what I want is to kind of show the functionality. So I want to have some endpoints. So let's just use okay, so we're going to move to agent mode. So agent mode is the one that basically will take our request, look at it as like a software developer, and then implement the things that we've asked. So what I want is so we already have this app, which is fairly basic, but that's fine, right? So we're like, okay, our app currently allows to add tasks to our Kanban board. However, we did not have a backend before. Now we are using Node.js. I would like to have a JSON file where our tasks are stored with the needed info. And then in order to provide it the information that it needs, right? We're just gonna click on the file, right? So we can add it to the context. So we're like, okay, this file needs to be read by the AI when it's looking at this. We're gonna give it our JavaScript. Okay, so here, hold on. So interesting. Let's see the shortcut for that. Yeah. Okay. I would also like to adapt our app.js. So I can say add app.js to, why is that not working? Oh, okay, sorry. I'm used to another code editor, so it's throwing me off a bit. So $ app.js to include the fs functionality. Okay, so at the moment we don't want to change a whole lot, so we're just going to say, okay, fine. So what we're expecting it to do is to add the file handling parts of Node in order for us to be able to write a file locally and to be able to store it. So everything in green is new, and everything that isn't colored is still like not green, and everything that it has removed is red, right? So it's like, okay, what you're doing here, this is just like template stuff. We're gonna get rid of that because there is no purpose for it. It's also going to be enabling cores for the local dev. We'll get into that a bit later, but if we don't do this, we'll have a lot of permission errors and whatnot. We'll explain what that does a bit later on. So it's like, okay, the server component is fine. It's importing the read functionality, the write functionality, the exit functionality from Node, right? So the Node file system component. It's also like, okay, fine, we're going to have a path. We're going to create a file tasks variable, which is going to be using a process for handling the directory, right? And it says, okay, this will be a tasks.json. So this is going to be a file that we'll have. Helper to read tasks from file, which is great. So it has a function. So this function exists within Node. The function is read task. So this is a function that is already existing. So it's not creating it here, but it's just calling the function. And that's like, okay, if the file doesn't exist, right? You're gonna have to create that file. And otherwise, you just exit out of it. And then it will try to read the file and then return the JSON.parse. So it's going to be returning a JSON file within like the JSON format. And if an error occurs, that when the catch occurs, so this is something that we already handled during the try catches in general JavaScript, because again, this is still JavaScript, but we are now thinking more about backend functionality in how we handle requests than writing out logic for within a browser, right? And then it's like, okay, function to write it. So this is for reading. This is for writing the file. Okay, so it got rid of all of this. Is going to be enable cores for the local dev, which is fine. Okay, so it's allowing it to get post and set options. We have the contact type, and then okay, that's fine. So it's just saying that okay, if the method is options, then you're going to give this as a response, which is a 204 response. Fine. And then we have, if the request is a get. So if we're trying to read something, okay, it's going to be saying, okay, we're going to create a const that's called tasks within this code block. And then it's calling up with a function. So this function, this is the one that was created here. So this is where the function was created in this file. And this is what the function does, right? So here is just calling it. It's like, okay, if you're trying to get information, so the front end is requesting to read, it's going to be like, okay, we're going to respond immediately with a 200 file, okay, with a 200 code, which says that everything is okay. The content type is application JSON, which is going to be the most common one that we're going to be using. The response, so the actual response that's going to provide is going to be the JSON dot stringify. So it's going to transform the JSON into a string, and then this will happen for the tasks. So again, the tasks is the variable that was created here. So this will be the results of the reading of the file. And then at the end, this is going to return. So it will exit out of this loop or of this statement. And then it's like, okay, if it's post, okay, and this is what gets interesting. It's going to be like, okay, we're going to create a body that's empty. So it's creating here a variable with let. So this is a variable that can change, right? So it's not a const. And this is empty. So it's just an empty string. And then we're going to be like, okay, the request, okay, data. So it's like, okay, the request itself, we're going to look at the data of the request. And then we're going to take that information, which is a chunk, and then we're going to take the body and add it to that, right? So we're concatenating the two. So we're taking the body and making that a part of our data. And then it's going to be like, okay, the end of the request is going to be a okay, so it's going to parse the body that we received as JSON. So it will turn it into a JSON object. It will read the tasks file, and then it's going to push. If you remember push, this was a array function to add something to an existing array. So it's going to be pushing the new information to tasks, and it's going to write the tasks, and it's going to finalize with like, okay, sending a request that the operation was completed. So yeah, I mean, it looks okay to me. And then at the end of the day, it's like, okay, if there was no response or like this operation couldn't be completed, it will provide a 404 saying that, okay, we don't have, we couldn't find the action that you're looking for. All right. Fine. So let's get rid of these console outputs. That's all good. Okay, so we're gonna keep whatever it told us. Yeah, this back, we really don't need it to do anything. So I'll comment all of this out. I'll comment this out as well. So we have our index, we have our package.json, we have our script. So I do want to highlight something. All right. So for the functions to read and write and create the server method, this is quite elaborate. So there is quite a lot in here for relatively little functionality that we will actually perform. But before we say more about that, let me just test this out and see whether it actually works. So before we do that, we will need to make sure that our server is up and running. So we're going to run our server again. Okay, so it's running again on port 3000. And at the moment, we are not looking to um, we're not looking to talk to the server directly. So what we actually want is for our front end. So this is the file. So if we write something in here, with backend, okay, it's gonna be tomorrow. We're gonna add the task. Now, we're expecting for this information to have gotten stored somewhere, right? Now, this tasks file that it is referring to, where is that stored, right? Because it didn't give us an actual path. So let's ask whether it has actually thought about that. Where is the tasks file being stored? Okay, so that's fine, but the file doesn't exist, right? So we don't have a tasks file, right? So the tasks file currently does not exist. Also, if we add a task from our front end, will this already be written to the tasks file? Because that did not happen, right? So we did add a task, right? It says, okay, the file is in there, but it's not, right? The task file will be created automatically the first time your backend receives a request to read or write tasks. However, your current front end, okay, only uses local storage, which we know already. At least, I mean, this is how we designed it last time. Great, right? So in our JavaScript, so if we go to our scripts, right, we're handling file here. And it's pointing out, indeed, so we are saying that we are pointing to the local storage. We are telling the browser. So here, when we are adding this, we are telling the browser that, okay, you need to store this in the browser storage. So that needs to change. Now, I know that, but I expected it to suggest something in that regard while doing the build. So again, this is why it's important for you to know already what it is that you're going to do, because the AI will easily skip things like that are like very evident. Because yeah, we're storing it locally, but I told it that I want it to be stored in a actual file on our file system, right? So it implemented all of these file system methods within the app.js, but it didn't do anything to change the way how our front end works to actually change that functionality. Okay. So it's like, okay, your front end currently uses local storage, which is great. Would you like me to update your front end to use the backend tasks? Okay. Yes, please. Okay, so now we can have a look at our front end very quickly to see what happened. So again, everything in red has been removed. The green is new. So this is the part that's quite important, right? So here we're removing uh, the storage key altogether. We're removing the local storage assignment, and we are in the script saying that okay, your backend API route. So whenever you want to store your information, this is the path that we're giving you. So normally, this will be an environment variable that you will have in your application. We'll get to environment variables next time. So it's like, okay, localhost 3000, which is where our server is, right? / tasks, which is going to be the file in where the tasks will be stored. And then it's going to be like, okay, try to do this information. So try to load the tasks. And again, this is an async await functionality. So the browser will send this request and will continue with other tasks if it needs to. And when it receives a response, it will handle it then. So here we're saying we're loading the tasks. So we're reading the tasks from the file. We are saving the tasks here. So whenever we're submitting them, so this is a post, right? So this is a post function or a post method. And for reading it, we are using a get method. And okay, yeah. So we're fetching here. So fetch again, fetch is asynchronous. Looks okay to me. Yeah, so add functionality, fine. Okay, so load task from storage. Okay, perfect. So we're gonna say, okay, that's all perfectly fine. We're gonna accept all of that. And let's just check on server. Okay, so server is still running. Let's go back to our browser. Let's refresh. And you see that all of the tasks have disappeared. So we're not reading from the local storage of the browser anymore, but we're expecting this to come from a file. So our first back and saved item, and let's do 1st of September add, and it added it. Now wondering, okay, so the server is still up and running. If we go here, we have a tasks.json, which is amazing. So later we'll be adding this, of course, to a database, but we haven't really handled or spoken about databases yet, which we'll get to shortly. But for now, it has given it an ID, which is randomly generated. We have the title, so the text of our item, and we have the date for which it was set. We can also test whether our logic is actually no, the logic was already broken before we did anything there. Actually, no, we fixed that last time. So already done item. So we're going to set this in the past, and then we expect that to be done. Yeah, which it is. And if we're going to set something for today, so now doing, we're going to set today add perfect, right? So if we're going to add something again for the future, anytime in the future is get added to the backlog, which is the functionality that we want. So anything in the future goes in the backlog. Anything for today will be in progress, and anything that has already that's in the past in terms of date will be in the done. So we see here that our JSON file is being updated properly. So our functionality is now basically in order. I want to touch on two things very briefly before we end the stream for today, which is a node monitor and as well as Express. So Express is a library or a framework for Node.js that simplifies setting up your APIs quite significantly. So it will basically turn your gets and post methods and whatnot into like just a couple of lines instead of everything that we have here. So in order to show how that works, I'm just gonna ask our friendly AI. I currently don't use Express. I would like to add it to my project and adapt my to use Express instead of the node functionality. Okay. Okay. So this should, I mean, Express is very, very commonly used in combination with Node in order to, again, simplify your API routes. And you're going to see the result of that very, very quickly. So our app now using Express point file storage remains the same, but the code is cleaner. Okay. You'll need to install Express and cores in your project. Would you like me to provide the command? Yeah, sure. Yes, please. So it's going to give us two commands. One is to install Express and cores. Oh, continue. Yeah, sure. I don't. Yeah, okay. So it's opening the terminal in here, like in the IDE, and is going to run npm install cores. Okay. So it was installed. Okay, so something important that you need to see here. So we basically install Express and cores. And because we added these two libraries, they have added 69 packages to our application. So basically, all of these are dependencies that these two frameworks use to do their thing. And if we go now to our package.json, you will see that we have not added much at all. Okay, sorry. So the package.json still holds our like general project info, but you have now dependencies in here that are Express and cores. But also we have a package lock.json, which basically provides all of the dependencies for the libraries that we use. So basically everything that is here is a dependency. They might have their own dependencies, and all of these are listed here. So you can see that, but just by adding these two frameworks, we've added a relatively large number of dependencies to our application. And this is something that you kind of need to evaluate for yourself if sometimes using a specific library is worth it, especially if a library is not very well maintained, because again, like most of these libraries are open source, free to use, are maintained by a small group of community or maybe a company as a side project. But they might also introduce vulnerabilities. So these two are like things that almost everyone uses who just uses Node.js. So these are very well maintained, and you see that we have no vulnerabilities currently, because you might have some. So if you use an outdated version, that's why it's important to update these every now and then. You might have vulnerabilities that are known, and then it's important for you to update your application in order for your application to remain secure. So we've now installed Express and cores, and the functionality is the same. All right. But you see that it has removed all of this and just replaced it with this block. It's like, okay, const app express. We're going to use cores. We're going to use express.json for the JSON parsing. for the get method, everything that it has removed is basically implied. So that's something that Express does by default. You're like, okay, just give us the response and that's it. And just the JSON.task, we're done. For the post, this is mostly the same. This didn't like change a whole lot. But it did make our code significantly smaller. And if you're going to have more endpoints, which you would naturally have in a bigger application than just doing what we just did, this will just simplify your code base by quite a lot. So here, why are we? Okay, so it's just changing the server listen to app listen because now it has called the app instead of server, which is fine. So we're going to keep it. That's great. Now we'll come to the next part of what I wanted to show before we close for today. So I'm gonna refresh this, the new tasks, and I'm gonna select the date, add. That works fine. Okay, so okay, good. So there is a okay. So in our index, so I just want to change something very quickly. I'm just wondering whether it's something that we should jump in now or leave for next week. You know what? We still have quite a lot of things to cover in terms of like setting up our backend. So let's leave that for next week because we're already a bit over time for today's session. So we've basically set up our backend locally, right? So we have Node installed, we have Express up and running, we initiated our project with npm, we have cores installed, which just gives you like kind of bypasses a lot of permission issues that you might otherwise run into by running your server locally, and your browser or your application will start to complain about access to things and whatnot. So this is going to be one of the cornerstones of like getting our project in a state where we're like, okay, we're now ready to really start building. So the foundation is there. We've covered everything that has to do with the front end. We've now covered quite a lot of things that have to do with the back end. I'm going to be posting quite a few links as like additional reading and reference material in the Discord server. So you can look into those. So for this week, or at least like from today until next week's stream, the target for you guys is going to be to make sure that you have VS Code installed, that you have your project, like a very minimum version of your project built with the GitHub Copilot. For the front end, again, very basic, no frameworks. So do tell your AI to just use HTML, CSS, and JavaScript initially. Add your backend with Node. So make sure that you have Node installed. You can install Homebrew. You can use Homebrew on Windows as well. It's not only for Mac, but yeah, it really depends on your preference. You can then install Node like we've run through today. Set up your Node by initializing your project. Look into how to get your app to use the backend properly, right? Make sure that you're using file storage as well. And apart from that, just play around with like adding functionality to your app, understanding how that functionality interacts with the backend of your application. I hope it's now become more and more clear the differentiation between the front end, so your users UI and what they see and interact with, and the back end and what that does, right? Because next week and the week afterwards, we're going to be building on that information and on that foundation to make sure that we have all of the fundamentals in place to start really building our app. Because from that point, it will go quite quickly. So we're going to be entering a planning phase where we'll predetermine what our app needs to do and look like, and the technologies that it's going to use. And then we're going to be leveraging the AI model that we're going to be using in order to set up the foundation of the application and then build every part of it gradually instead of having the AI build everything all at once. Because as closing, one thing that is also very important to keep in mind when you are utilizing your AI is that the AI has a context window. So there is a maximum amount of memory that it has to store the information that's relevant to what it is currently doing for you. So that's why we're going to be building our application in chunks so that we can give it the context that it needs in a new chat. And we're going to be like, okay, do this now using these files and this reference, right? And it's going to build just that. So that we don't like start building the app and just adding things and adding things and adding things, because at some point when the memory size or when like the token context window will be full, it will start to lose the context. So it will start doing things that you didn't ask for, or it will forget what it just created itself 10 minutes ago, and it will start overwriting things. And this is something that we need to avoid. So we that's why we pre-plan and then we add to our application gradually, as well as we're going to dive into, setting up our GitHub, setting up Git in order to do version control so that we can build our application gradually, push it to GitHub, continue with the next component. And only if that component is good and we're happy with it, then we're pushing a new version to GitHub so that we continuously have a version of our application that is saved periodically and that we're happy with in that state, so that we can keep our application in growing in a good direction. Because you will have moments where the build will break. You'll add something that has all kinds of unexpected effects, and you're like, okay, I don't know where this is heading, but this is not good. Let me undo everything that I've done so far and maybe do a bit of research, maybe look into using a framework or a library, or understand better, maybe you're interacting with the system and you thought that it worked in a specific way, but it works differently. So that is something that is important to keep in mind, and we'll continue with that next week for sure. All right. So this will do it for today. Thank you again for joining and watching and participating, and wishing you a great day, and see you next week. Take care, everyone. Bye bye.